Hey everyone, welcome to episode 1 of On-Chain with Chaskin. If you're excited about Ethereum, privacy, and innovation in the blockchain space, then you're going to love what we're diving into today. Today we're talking about a revolutionary platform that's making a major impact on data privacy and verification within the Ethereum ecosystem, Sismo. But our conversation doesn't just end at discussing it. We're also hands-on, building a dApp with this innovative technology. Let's do this. Sismo was founded in late 2021 by Hadrian Terlanes and Leo Sayu. Both software developers, Hadrian has been working within the Ethereum ecosystem since 2015. His experience includes roles at influential teams such as Consensus and more recently Aave. Driven by the belief that zero-knowledge proofs could empower individuals with full control over their data privacy, Hadrian launched Sismo to make it simple for developers to tap into this potential.
We want privacy!
No, not like that, Harry and Meghan. Actual privacy. Sismo's flagship product, Sismo Connect v1, is now live on various blockchains, including Ethereum Mainnet, Arbitrum 1, Polygon POS, Optimism, and Gnosis Chain, with more chains on the horizon. Sismo Connect provides a privacy-centric method that allows for the creation of zero-knowledge proofs right in the front end of your app. This enables not just the verification of asset ownership, but also the validation of a diverse range of data points, including your follower account on Twitter, all achieved in a manner that safeguards users' privacy. This potent tool effectively equips your app with the power of multifaceted data verification while maintaining the highest standards of data privacy. The type of assets validated could range from an NFT, at least a specific balance of an ERC20 token, your status as an Aave DAO voter, or having a certain Gitcoin passport score. But what makes Sismo Connect even more fascinating is its capacity to extend privacy-preserving data validation to off-chain activities, such as your contributions to a certain GitHub repo or that you're active in a community. This effectively bridges the gap between the on-chain and off-chain worlds, all while ensuring that your data privacy remains uncompromised. To utilize Sismo Connect, your starting point is the Sismo Factory. Here you need to register a Sismo Connect application to acquire an app ID. This process involves signing in with Ethereum, providing basic details about your app, and registering authorized domains. The app ID becomes the unique identifier for your application. Separately, you need to create one or more data groups for your app. These data groups comprise the specific data requirements for your users. These requirements are what you'll use as the basis to request proofs from your users in the front end, and then verify those in the back end or in your smart contracts. From the user side, you first need to create a data vault where you aggregate together all of your Ethereum and off-chain social accounts. Currently, Sismo is compatible with GitHub, Telegram, and Twitter. Once your data vault is set up, you can initiate the verification process via the Sign In with Sismo button. This action redirects you to a page outlining the specific data requirements you need to prove. From here, you can proceed to generate the ZK proof. The system then checks for verification based on the collective accounts in your data vault. This ensures privacy by allowing the generation of the proof with any of these accounts. For instance, if you want to prove ownership of a Pudgy Penguin NFT and you have 5 Ethereum accounts in your vault, you can generate a proof that you own the penguin regardless of the account that you're actually signed in with at the moment. This introduces a new level of privacy to Ethereum by allowing you to add new accounts to your data vault without any links to the existing accounts already in it. This offers a privacy solution on Ethereum that hasn't been previously seen since something like Tornado Cash. Sismo Connect's potential extends to facilitating cross-chain asset verification, implementing simple resistance mechanisms, or enabling functionalities like a gated Telegram group chat. In addition to Sismo Connect, the team has also launched an app store. This platform serves as an aggregator of applications that utilize Sismo Connect. From this one page, users can explore various applications, from those allowing cow token holders to claim CowSwap merchandise, to granting exclusive entry to events at ECC. As per Hadrian's tweet on June 23rd, Sismo's future roadmap aims to further simplify the integration of ZK proofs in your app. With the App Store already live, they plan on continuing to push the boundaries of ZK proof usability. Also, the specifications of Sismo Connect v2 are already in the works, promising exciting developments ahead. Now, let's head back to my computer and build a dApp using this cool tech. Welcome to the tutorial. In this guide, I'm going to walk you through the process of building a cross-chain token-gated NFT mint. This will require users to own the Coinbase Stand with Crypto Shield NFT on Ethereum Mainnet. The objective is if that they own that NFT, then in a privacy-preserving way using Sismo, they are allowed to mint our Arbitrum Shield NFT on Arbitrum Goerli testnet. First, we're going to take a look at the Coinbase Shield NFT that users will need to own. Then we'll check out our Arbitrum Shield NFT that they'll be able to mint. Following that, we'll demo what we're going to build before getting into the code. This is the Coinbase Stand with Crypto Shield NFT. They released this NFT last month when they got sued by the SEC. All proceeds from this NFT mint go to support crypto advocacy groups. This is the NFT that users will have to own on Mainnet in order to mint our NFT on Arbitrum testnet. Speaking of our NFT, let's click on over to testnet.opensea.io and check it out. This NFT is of an astronaut holding a shield. The Midjourney generated astronaut fits perfectly with Arbitrum's space theme, and the shield represents solidarity with Coinbase. Let's switch on over to our dapp and check out the demo of what we're going to build. Here we see that we need to connect our wallet. I'm going to connect using MetaMask and switch over to Arbitrum Goerli, where the NFT is. Now it displays the address that the NFT will be minted to, the same address we just connected. This is significant because we're going to utilize the data vault. It's where the user can store all of their addresses, and as long as one of them has the data that the dapp is looking for, in our case, a Coinbase Shield NFT, then they can mint our NFT without any link to the address that actually holds the shield. To emphasize this point, it doesn't need to be the address we just connected to that holds the Coinbase NFT. As long as one of the addresses in the data vault owns the Coinbase Shield, then we can generate the ZK proof, present it to the smart contract saying that one of our addresses owns the shield, and then we can mint it. Okay, let's move ahead and mint with Sismo. This is now redirecting us to the page where the ZK proof will be generated. Since this is a demo, we're impersonating none other than Brian Armstrong, as you can see here. We're going to create the app name and the logo that you can see here, as well as this data group, which is next to membership, that says the user needs to hold at least one or more Coinbase Shield NFTs in order to generate the ZK proof, which we will do now. This is all happening on the client side, so the smart contract / the public ledger has no access to anything that's happening now. They're just able to see the ZK proof that's presented on chain when we clicked mint. And there we go. We just minted a cross-chain privacy-preserving NFT. How cool is that? Our first step is to create an app ID. This is needed in both the back and front ends. This is achieved by navigating to the Sismo Factory website at factory.sismo.io. And then we need to log in, which requires us to sign a message to prove that we own this wallet. All right, now let's click Explore or Create New Sismo Connect Apps. Create a new Sismo Connect app. And we can name this and make the description whatever we want, but let's just do Sismo Walkthrough, description, a cross-chain token gated NFT. And the domain is going to be localhost 3000 since we're not going to deploy this live. For the logo, we'll just do Coinbase's shield and submit that. Now we have our app ID. Let's copy that over just so we have it. Now let's make a data group. So this is the data that we're going to be requesting from our users. Oh, it already saved this in. Coinbase NFT shield holder. Let's add in eligible accounts. From data providers, we need holders of a ERC 721 token. Now I already have this up from earlier, the Coinbase shield, and you can see the address is right here. So I copied that, paste it here. It's on mainnet. And now it takes a minute to load up the addresses. In the meantime, let's take a look at what other data that we could get. You could take a look at Lens or GitHub, Safe, Unlock. There's so much cool stuff that we could use. Mirror, big fan of Mirror blogs. Even DGen score, pretty funny. All right, 0, that's a mistake. Let's copy that out and paste it back in and try again. And there we go. There's this many eligible accounts. Let's add them. Let's have it update daily. And now let's make some descriptions. These don't really matter, but let's say holders of Coinbase Shield, and the same here. Doesn't matter. When you do this, you should request to deploy a new one, or you can just copy mine because it's all public. But I'm not going to do that because that takes some time. Let's go back. You could try to find my data group again. We can just search through all of them. So look, Coinbase Shield holder. You could search Coinbase Shield and just copy the group ID if you don't want to create your own. Let's go back. Let's copy in the group ID. All right, time to get to work on the smart contract. We're starting off with some boilerplate code. You can find the link to this repo called Sismo Walkthrough in the description. If you'd like to code along, I'd recommend cloning the first commit labeled 01 boilerplate. While we could start from scratch, this boilerplate allows us to focus on Sismo's features and less on setup details. I'll explain everything I did up to this point, don't worry. First, I set up a new Foundry project executed by running forge init. I've included a .env file containing my private key, the Arbitrum Goerli RPC URL, and my rbscan API key. If you need to retrieve your private key, it can be exported from your wallet. The RPC URL can be obtained from Alchemy's website, and the rbscan API key from rbscan's website. Please remember to double check that the .env is included in your gitignore file. If it's not included, you might accidentally push up your private key to GitHub. I made this mistake once and I lost all my Goerli ETH. It was a sad, sad day. All right, anyways. Contained within the source folder is a basic NFT contract called Arbitrum Shield. We'll be adding to it later. I installed OpenZeppelin via their GitHub name using the command forge install openzeppelin/openzeppelin contracts. The link to their GitHub can be found in the description. I also wrote a simple deploy script. I already went ahead and pinned the NFT's metadata to IPFS. The test file has been omitted just to keep this video short, but please remember to always test your contracts before deploying them to mainnet. I also made some adjustments to the foundry.toml. Please make sure that the code matches the settings here. Let's move on to the client folder. So I initiated a new Next.js 13 application integrating Tailwind and TypeScript. I erased everything in the globals.css except for the essentials for Tailwind. Inside the page.tsx, I erased everything except for some basic stylings and the word hi. I installed the packages needed for WAGMI and RainbowKit, and I made a WAGMI provider. Essentially, all you do here is just copy and paste from RainbowKit's website. It's extremely easy to follow along. One thing of note though, Alchemy ID is your API key, but I kept it the same just to stay consistent with the documentation. Remember that it's a client component because this is happening on the client side, and then we wrap it around our app to keep the boilerplate of the code server side. Also note that we changed this in the next.config.js. That's just copying from RainbowKit's website again. Now that we got that out of the way, let's get on to the meat of our dapp. The first thing we're going to do is take a look at the Sismo documentation in order to download their packages. So that's forge install sismo-core/sismo-connect-packages. And it wants me to do no commit, so I'm going to do that. Now I already went ahead and downloaded the packages, so it's going to take a little longer for you. Next, I'm going to copy this command from their website in order to create a remapping. So we could easily just copy this over. And there we go. We just imported their Solidity files. Let's inherit the smart contract that we need, which is Sismo Connect. And that has a constructor, which we're going to paste in. The constructor takes in a function which takes in two variables. And they are bytes app ID, byte 16 to be exact. And bool is impersonation mode. The app ID is this, and the is impersonation mode we're going to set to true because we are testing and we're going to pretend we are none other than Brian Armstrong himself. The next thing we need to do is we need to paste in this line in order to use a library from the Sismo lib. And this library allows us to help check the ZK proof in this mint function. So this mint function is going to take in a bytes memory response. It's the response to the front end. The front end is going to create a ZK proof on the client side and then send it into our smart contract. And then we want to do some sort of verify function to verify that this smart contract is correct. And if it is correct, then they're allowed to mint. If it's not, well, sorry, no Arbitrum shield for you. So let's change the name of this mint function to be something more descriptive. In the docs, they have Sismo Connect response, and I like that. And now I'm going to copy and paste the function from my repo that is used to verify the ZK proof. I'll explain to you everything what's happening here. So the verify function is from Sismo Connect, and it's looking first for the response bytes, which is the ZK proof that's sent in from the front end. Next, this auth checks what type of request that it's looking at. So is it checking to see if it's vault, which means it's something in our vault and it's something that's on chain. So in our case, yes, it's something on chain. But if it was something social like GitHub or Twitter, it would be a different auth type. The claim, we're building the claim with one group ID, which is Coinbase Shield group ID, which is this, which we should make a state variable. And that is also byte 16. Yep, that is right. Thank you, GitHub Copilot. And now let's make a getter function for it. Thank you, GitHub Copilot again. This claim type of GTE means greater than or equal to. So they need to be holding at least one Coinbase shield in order to mint. So if they're holding 2, they're still allowed to mint. If they're holding 0, hit the road jack. And lastly, this signature is just used to prevent somebody from front running us, because that would be bad and would make me sad. That's all that needs to go into the verify function in order for it to check the ZK proof. And if you just entered in like random bytes like 0x69123, then it would revert and you would not be able to mint. And that's it. Our smart contract's good to go. Let's clear this and do forge build to make sure that everything is good. Right, okay, the issue's in our deploy script. That's good. That is good. Let's move over to the deploy script because that's the next step. I'm going to erase this console log because I don't want you stealing my precious Arbitrum Goerli ETH. And now this has 2 additional variables going into the constructor. It is the app ID. Nope. Let's double check that that's right. 49 or 48.9. 48.9. Yeah, that looks right, but let's just copy it to double check. Can't hurt. All right, cool. Now the next thing is a Boolean, which is impersonation mode true, because we are lying about who we are. And let's import that in, let's make sure the order is right, after the URI. So app ID is impersonation mode. Now let's try to build that up. Nice, they both compiled successfully. Now let's write a script to test to make sure that it'll deploy correctly. Oh wait, before we do that, we need to do source.env. This is important or it's not going to work because our environment variables aren't loaded up. Now we can do forge script / deploy. Yep. And now the name of our deploy scripts --rpc -URL, and our RPC URL is called Arbitrum _Goerli. There's an E. Goerli URL, RPC URL, sorry. And let's give this baby a test run. All right, cool. The simulation worked. So now we can send it live. We want to broadcast it. We want to verify it. And we want to be able to watch along at home. I always enjoy watching my contracts get deployed. Thank you, Foundry, for allowing me to join you on the journey of deploying. All right, cool. Now it's in the queue to verify. I don't like when it says not okay, but give it a minute and we could speed this up kind of by copying the address because we already know the address now. And there we go, we deployed it. Now let's just paste in this address so we have it. And cool, let's move on to the front end. Let's open up the client folder right here. Since this is Next 13, let's open up the app directory and the page.tsx. And let's start a local server and make sure it still says hi. So I opened up a new terminal and now I'm cding into client and doing npm run dev to start a local server. And let's refresh this page and make sure it says hi, or else I will be sad. It says hi. The first thing we're going to do is make a heading. Now I just want to emphasize that the focus of this tutorial is on Sismo and not on styling. So it's going to kind of look like poop. But yeah, I'm doing the minimal amount of styling to still make it look not terrible. And Sismo walkthrough. Nice. Since this is a web app, a Web3 app, it would not be complete without a Connect Wallet button in the upper right-hand corner. So let's do that. Import from RainbowKit. RainbowKit makes connecting your wallet extremely easy. If you're not using that package yet, I highly, highly recommend it. And let's absolutely place it in the upper right-hand corner. Let's take a look to make sure it's there. Perfect. Now this is all happening server side, and the meat of our app is actually going to happen on a Sismo client component, which we haven't made yet. So that's why there's that red underline, but we're about to make it right now. Here's a shortcut for you. If you click new file and now do components, the name of the folder /sismo.tsx, the name of a file, it'll put that file in a folder, and then rfce in order to quickly make a React component. Now let's import that in here now that it's made and make sure it's saying Sismo. All right. So this is going to be a client component, so don't forget to put use client at the top. And the first thing you want to do is use a WAGMI hook called use account. And from this use account, we want to pull out is connected and address. Thank you, GitHub Copilot. And what we want to do is if you're not connected, we want to make it conditional and show a paragraph telling you to please connect. And underneath, let's show another connect wallet component. All right, so there should be nothing here now because we are connected, but let's disconnect. And there we go, that's what we just made. So the next thing we want to do is if we are connected, what we want to show is the address we're connected to, or the NFT is going to be minted. That will be the NFT destination address. Your NFT destination address, too many Ds. Address is address, and that's what we're signed into right now, connected to. Sorry, we should put this in a div. And I'm using option click to move that around. Okay. And underneath this, we're going to make the Sismo Connect button, but we're going to put this inside of a div just so it's centered. So flex, justify, center. And now I would highly recommend copying this from either the documentation of Sismo or my repo and paste this in. This is the connect button that's going to go right here. We have a lot of red underlines. VS Code is mad at us because what we need to do is download the package that has this component. So let's do npm install at sismo core / sismo connect react. Click enter. And that has a lot of what we need here, but not all of it. I'm going to walk you through it all, don't worry. So let's go through and import what we can, which would be this Sismo Connect button. We're going to make this config object. We can import auth type. We're going to work on these in a second. So the Coinbase Shield group ID, which is what we've worked with now a million times. So let's copy that over. And let's make that a variable up here. But we want this to be a string. And now we're going to make a state variable for this response bytes. Now, what this is on the front end, when we make the ZK proof, we want to set the bytes, which is the ZK proof, as this response bytes. So it could be entered in here as this bytes response. So let's make a state variable. And thank you, GitHub Copilot. Import in useState. And so that went away. Now let's get rid of this sign message. What you want to do here is either in the repo that Sismo has of their on-chain tutorial, there is a folder called utils, and then the file is misc.ts. Or I have that exact same one in my repo, so you can look in either place. And let's make that in our setup now. So new file, it is utils/misc.ts. And let's copy this in. Don't worry, I'm going to walk you through what we just pasted in. First, sign message allows us to sign a message, which is what we need to do in order to prevent front running. So let's import that in here. So that's the same thing that's happening right here, which I told you guys about earlier, and gals. All right, so let me go through the rest of these. Format error, nobody's perfect. In case that there's an error, we want to be able to format it and display it on the screen. So this is just an easy way to format that error message so it doesn't look like boop. And then here's the error ABI, which is all the possible errors that can be displayed when working with the Sismo Connect smart contract, like it says right here. All right. So now let's make this Sismo Connect config object. This is pretty simple. I'm just copying it from my repo, or again, you can copy it from the docs. The only thing is we need to import in this type, and we need to paste in our app ID, which is here. And we're impersonating Brian Armstrong, but if you want, just for fun, you can put in your ENS, so your ENS.eth, or you can impersonate Vitalik, or I don't know, whoever you want. But we're just going to do barmstrong.eth. Okay, all the error messages went away. That is good. Let's check on our front end to make sure everything's working. And it's redirecting us to this page, which is exactly what we want, showing we're impersonating Brian Armstrong. This is the name of our app, and Coinbase Shield holders is what we're checking for. Perfect. Let's go back, because we don't want to generate the ZK proof right now, because we didn't make a mint function to submit it on chain. So let's move on to the next step, which is going to be if we're connected. So is connected and response bytes. What we want to show, div. Then inside that div, let's paste in the destination address again, just to like really hammer it home. And now let's make a button. And this button is going to say mint, because we're going to mint that NFT. And let's change some of the attributes of this. I'm going to put on some basic classes just so it's not just randomly saying the word mint. Border, rounded M, yep. Okay, well, that'll show once we generate the ZK proof. That actually shows that it's working because the response bytes is empty. So that's why it's showing the mint with Sismo and not the mint button that we have here. We want to disable it if there's an error, which we don't have yet, but let's make a state variable just in case there is an error. We're going to get to that soon. Okay, so definitely want that disabled in case there's an error. We also want onClick to call a function called mint NFT, which we have not made yet. Let's make the boilerplate for that function right now. It's going to be an async function. And let's do try catch finally. And let's make loading states for now. So set loading true and set loading false. Let's make that a new state variable. Thank you, GitHub Copilot. And let's make it disabled also when we're loading. And now let's add in that error. So catch, we want to set error, but we want to format it using that helper that we got from utils. So there we go. It's getting mad about the type, so let's do any. So now that is what we want, but Mint NFT is not doing anything. We need to talk to our smart contract. We're going to do that with WAGME. If this is your first time working with WAGME, there's two hooks to interact with a smart contract. First, we need to do use prepare contract write. Now what this takes in is an object, which is the contract inputs. So let's call contract call inputs, which we haven't made yet, but this is going to return a config, which goes into the next hook, and an error, but we already have something called error. So let's call this WAGME simulate error, and let's make this variable. We want this to be empty if there's no response bytes, so it's not constantly pinging our RPC. So let's do a conditional, and if it's empty, let's make it empty. Cool. If not, we want the contract address to be what we did earlier when we deployed it. Next to the ABI, let's first put in the errors ABI from the utils, and we need to get our ABI. So if this is your first time working with Foundry, then in order to get the ABI, we have to look inside the out folder, find the name of the contract you just deployed, find the JSON. Let's start from the top. The first thing will be ABI. So let's copy this array. And once we get to the bytecode, we don't want that. That's what goes on chain. We want the ABI. And we're going to paste that into our client folder, make a new file in a folder called ABI. Let's call it abi.ts. Const ABI equals what we just copied, and do export default ABI. Now that we could access it here and destructure it. Did we not? Yeah, we did not import it. Now it's imported. Now the function name that we're going to call, let's copy that from our smart contract, just so we know we're not going to make any typos, knock on wood. And lastly, the args, which is the response bytes. There's a type error. So in order to fix this type error, what we're going to do is we're going to look in this misc.ts. We're going to copy this assertion. Now this assertion kind of makes sure the address is the type that WAGME likes, and that should go away. And now what we're going to do is we're going to run a use effect just to make sure there's no errors on our simulation. And if there is, we can display it before the user even calls our mint button or calls our smart contract. If we want to check here, if there's no WAGMI simulate error, that is what we want, we return. If there is an error, but it's because we're not connected, then that's okay too. And we'll just have the user connect, and let's put that here to get rid of the error. But if there is a WAGMI simulate error and the user is connected, then let's set that error variable. Yep, and we're going to use the format error, and let's display that underneath everything. Make sure the user is connected, and yep, that's good. But let's add the minimal amount of styling, and let's make it red, just so you know something's wrong. This is not good if there's an error. We're almost ready to call our smart contract. Now we're going to use the use contract write, which returns write async, which allows us, when we call, yeah, that's what we want. When we call this function write async, this is what actually calls our smart contract. This is just doing a simulation, pinging our RPC, it's getting the gas, it's making sure that there's no errors, and then once we have that set in the config, we plug that into use contract write, and this function allows us to actually call the smart contract. That's what we're gonna call when we click mint here. So mint NFT calls this function, which first we set loading to true. Let's actually move that above the try. Then what we want to do is return this TX from await use async, but it's going to be, yeah, I know. It may be null. So there we go there. Here we want to return the TX receipt. That's not what we want though. Now we're going to use another WAGMI hook called wait for transaction. This is from @wagmi/core. This takes in an object which has a hash, and in order to get that hash, this is what our write async only returns one thing, this TX, and this TX has one thing that you could call hash, and that's what we want to put in here. This is another TypeScript error that we can just get around by making sure that the TX returns something. So let's paste that here and make it conditional. That should get rid of the error. Let's just double check to make sure that it returns transaction was successful. So if TX receipt dot status equals success, then we're going to make a new state variable, which is minted, and set it to true. But we don't have that yet, so let's go make that. Thank you. One thing that we want to change is, let's change the text of our button. If it's loading, then what we want it to say is minting ... And if not, we'll just say mint. Now that that's successful and it's set to true, we're going to have our final conditional is, yep, we want all of those, but we also want one last one, response bytes. This is just to double check that everything's there. And let's make the final div. Congratulations. You've just, I want to capitalize, minted the NFT to, and then let's get that address variable again. And to get rid of this red underline, let's copy this. One final cleanup, now that we have this minted variable, we want to make sure that the minted is false when showing these conditionals. And here as well. Here as well, we also want to add the response bytes. So no minted and no response bytes. All right, let's give it a go from our local server. Let's click Mint with Sismo. Let's now generate this ZK proof. There we go, it's generated. And this is why you look at your local server. Although it doesn't matter, I still want the formatting to not look awful. So where is that mint button? It's here. Let's, in this div, do text center. Perfect, that's in the center. Now let's click mint. Confirm our MetaMask, no errors. Let's move that to the center too. Let's go back. Congratulations, you've just minted the NFT. Now let's go to testnet.opensea and check it out. Paste in our address. Minted 32 seconds ago. We have this Arbitrum shield astronaut guy. Good job, guys. This was an awesome project we built. That wraps up our overview of Sismo and the project we built today. I hope you found it insightful and interesting. If you did, please hit that like button. It helps a lot. And I'd love to hear from you. Let me know in the comments which project you'd like me to cover next. Thanks for tuning in, and see you in the next one.